Hi there everybody and welcome back to ASFC Chemistry for Volume 4 of our online tutorial series for those of you starting out A-level chemistry. In this video we're going to introduce pH calculations because you're going to be pretty familiar with what the pH scale actually is from when you've been at school, but actual pH calculations are something that we start in the second year of the A-level course. Check the timestamps in the video description if you want to go through a specific part of this video right now, and you can also click the little eye to the top right hand corner of the screen if you want to find one of the earlier volumes in this online series. Otherwise, let's get started. pH calculations can be found in the second year part of an A-level chemistry course, and it is a really rich area of content. However, there are some parts of it that you are capable of doing as part of your early days in A-level chemistry. Specifically, looking at the pH values of strong monobasic inorganic acids is something that links directly to the content you've already covered at GCSE. Let's explain what each of these terms means. First of all, from GCSE you should be familiar with the term acid as something that donates an H+ ion, and you should also be familiar with the term strong, which means our acid dissociates completely when in solution with water. For example, hydrochloric acid is a proton donor which dissociates completely into H+ and Cl- ions. Now, hydrochloric acid is another example as well of a monobasic acid. That means it donates one H+ ion per molecule of HCl. Finally, the term inorganic means there are no carbons in our structure because our acid was derived from minerals. There are two specific strong monobasic inorganic acids that we're going to study as part of this introduction to the course, and they are the aforementioned hydrochloric acid, HCl, and we're also going to look at nitric acid, which is HNO3. So what actually is pH? What does that scale represent? Well, pH can be described as a measure of solution acidity expressed on a logarithm scale. Effectively, all those pH values that you've been familiar with throughout school are telling us how much H+ there is in our solution. If there is a lot of H+ from a very strong acid, for example, like HCl, then we would expect the pH value to be very, very low. Now, how we get that pH value is by the calculation you can see on screen now. pH equals minus log of the H+ ion concentration. And for the two acids that we're going to be studying, remember that's HCl and HNO3, you can see them at the top of the screen now, the concentration of those acids is the same as the concentration of the H+ ion they donate, because they dissociate completely in aqueous solution. For example, if I knew I had a 0.3 mole per decimeter cubed concentration solution of hydrochloric acid, well, that solution would have a 0.3 mole per decimeter cubed concentration of H+. Then all I have to do is put that number into the calculation you can see on screen. Let's have a look at how we would do that on a calculator. On screen now you can see a little snippet of my calculator, and you can see there that I've also circled up for you the log button that we're interested in order to calculate the pH of our strong monobasic inorganic acid solutions. So if I had a concentration of our strong monobasic inorganic acid, all I need to do with my calculator is press minus log, that you can see circled now, and then I input the concentration of that acid solution. The answer I get on my calculator screen is then the pH of my acid. Let's have a look at some examples of this, and then what I'd like you to do is check that you can do the numbers on your scientific calculator so then you're familiar with how yours operates, as each can just be a little bit different sometimes. On screen now is our first worked example of this calculation using a 0.100 mole per decimeter cubed solution of hydrochloric acid. If you're not familiar with the units of concentration, mole per decimeter cubed, that mole dm to the power of -3 bit, well, those are the units of concentration. Now, into my calculator, I would literally type minus log 0.1, and it gives me my pH value of 1.0. You can also see on screen now, I'm using a pH meter to measure the pH of the solution, and this is an essential piece of kit that you will use as part of your A-level in chemistry, and you need to know is a way of measuring the pH of a solution. Just one final bit of further guidance with this first worked example. On screen now is a snippet of my calculator with the actual calculation input on it, so you can see how I've got that pH value of 1. Just make sure you can do this on your own calculator, and if you're curious about the scientific diagram, well, it's created using a website called Chemix, and I'll put a link for them in the video description. Here we have our second worked example, and I particularly like this one, not only because it uses nitric acid, which you're not as familiar with, but also because it gives you a pH value that is actually less than 1 and is a negative number. So let's say, for instance, I had a 1.5 mole per decimeter cubed concentration solution of 8GnO3, which remember is nitric acid. Well, if I put this into my calculator, minus log of 1.5, it tells me that the pH of my solution would be minus 0.2, and a pH meter would tell me the exact same thing, as you can see from the apparatus on screen. That's not a mistake. At GCSE and throughout school, you kind of learn that the limits of the pH scale are somewhere between 0 and 14. Well, if you've got a strong monobasic inorganic acid and it's got a concentration of greater than 1, then it's going to end up with a slightly negative pH value, and it's perfectly normal. I would encourage you to have a little bit of a play around with the numbers of these concentrations and see what kind of values you get. However, that could end up opening a can of worms for you though, because you might wonder how we can actually record the pH of alkaline solutions if we're only ever looking at acid concentrations. But I'm sure you'll understand more once you've got further into your A-level chemistry course. Thanks very much for watching this Introduction to A-level Chemistry Volume 4 tutorial. Click the links on screen now, or click the eye at the top right hand corner of the screen to be taken to the other volumes in this series and other related chemistry A-level videos. Until next time, happy revising!